Next, we'll discuss partial fractions. Partial fractions are only applicable if is less than the denominator. For example, in this case, since x appears twice the denominator, the combined degree will be x cubed, which is greater than the one in the numerator, and the partial fraction applies. The second requirement is that the denominator should factorize, right? Otherwise, how can you uh, do the partial fraction? It's not possible. Now, because partial fractions have these two conditions, the LCAT sometimes tricks you. They give you a higher degree in the numerator. For example, let's do the power 4 here. But in order to solve those questions, you have to do the long division. Hence, after the long division, you will have first of all a quotient at the test plus a remainder and remainder over quotient. In that case, the remainder would be a number which has a degree less than the degree of denominator and you'll have to factorize the remainder. It's very unlikely to give you a very complex question for this, but they can give you a very simple one where you can just just do the log division quickly and then solve the remainder part. Most often, you have linear factors in LGAD. It comprises 90% of the partial fractions questions. So we'll see that in detail first. So here is the question. You will have multiple options to choose from, but how to, find the right one? It's just that you have to separate the linear factors. I write them separately. And then you write A and B in the numerator when E and B are the constants which you need to find. First of all, you will multiply the denominator, this one, on the both sides, which will give you this expression because x plus 1 is cancelled out here on the left with x minus 1. And this similar concept for x plus 1 with b. After you did that, now it's very simple. Just need to eliminate a from the equation to find the value of b. So in order to eliminate a, x minus 1 should be equal to 0, hence we'll substitute x equals to 1, which gives us, if we simplify, and hence we have a value for b, which is 3 by 2. Now similarly, you can also, simplify 3 by 2 to 1.5 if you want, but 3 by 2 also works. It depends on what type of MCQs you have. We have decimal points and options. We may simplify it to 1.5, otherwise keep it as it is. Alright, now for the next one, find A, we need to eliminate B, and we'll take x plus 1 equal to 0 and we'll substitute x equals to -1. B will be eliminated and A would be equals to 1/2. Once you have these two values, the next step is to find the right option, and that is just look at the solution that you have 1/2 instead of A. So A is in the numerator, and if A is a fraction, that means you have to write down numerator here and multiply the denominator down there. That should be like that. Similarly for B, the 3 is here and 2 is down there. If you have this kind of option, well and good, selected. If the answers are in decimal point, then you should convert 1 by 2 into 0.5, and similarly 3 by 2 into 1.5. Both kind of answer works here. Now, what happens if somehow give you a question which involves quadratics in the denominator? And those quadratics are reducible, that means you can factorize them. So I will call this term as factorizing. Okay. For example, 1 over x square minus 1 is equal to two partial fractions. Find that. Or maybe let's say it was not 1, it's equal to 5. Now, actually, what it appears like is a quiet equation, but if you remember the formula a square minus b squared, you know that you can factorize it as x plus 1 times x minus 1. And hence, now you can apply the partial fraction like that. The same thing happens, you multiply with x squared minus 1 on both sides. So the left, all of the denominator on the left side cancels out, and then you are left with this kind of expression. Now you need to be quick in the LUMS, so just assume that x is equals to 1. So the left side remains as it is, that it will be 2 times p, and hence you got the value for p. Similarly, now just assume that x is -1. So -2a, and very straightforward, 5 over -2. You have both of the values. The a is a negative, and when replacing, you should have a negative sign here. The negative sign is often written down in the numerator. So if you have 5 over -2, it can also be written as -5 over 2 or -5 over 2. And most commonly, they have the negative sign in the numerator, so look for that in the answer. Similarly, b is 5 over 2, hence it would be 5, and 2 would be in the denominator.